Hi, I'm Rebekah Koehn, and this is Molly. Molly is 65 and loves to garden, but she has severe knee osteoarthritis, which is marked by the painful degeneration of her knee cartilage. This orthopedic condition makes it difficult to go up and down stairs, stand up out of a chair, and it prevents Molly from kneeling in her garden. Soon, Molly will undergo surgery to replace her knees, joining the hundreds of thousands of Americans who receive this surgery every year. Each of you watching at home right now are actually in the process of developing this age-related condition as I speak, and many of you will eventually need knee replacements. Unfortunately, 1 in 5 patients are dissatisfied with the outcomes of this surgery, and Molly doesn't want to be one of them. Previous research on improving surgery and recovery has focused on what techniques the surgeons use, the shape of the implants, motion of the knee, muscle strength, and many others, but we still don't have a clear answer on why many patients are dissatisfied. Rather than focusing on mechanics, I came at this problem from a new angle, with neuroscience. When we walk, our nervous systems send messages from the brain and the spinal cord down to the muscles. Rather than controlling muscles individually, I study how the nervous system controls muscles in groups, like those in green, blue, and purple on the screen. And we call these groups modules. If our nervous systems use the wrong modules at the wrong times, we have trouble walking. My research focuses on using this neuroscience combined with engineering techniques to learn more about why people like Molly aren't able to move like they want to. First, I wanted to know what Molly's module groups looked like and if it was possible for them to change. So I studied modules and walking ability in patients before and after knee replacement surgery. I learned that patients who improved in walking ability throughout recovery also had changes in which module groups they used at certain times. This means that they naturally reorganize their nervous systems throughout recovery. Considering changes like this usually occur over decades or as the result of brain injury, this was a surprising finding in people with an orthopedic condition. And it made me wonder if it's possible to intentionally change modules. I'm in the process of investigating whether or not we can challenge the nervous system to reorganize itself so that it activates the right module groups at the right times. One way to challenge the nervous system is by resisting and limiting joint movement. So using a combination of experiments on a treadmill and computer simulations, I will study how joint resistance as well as muscle strength and walking ability may be related to muscle control and modules. While my work is ongoing, the findings could open opportunities for new and novel rehabilitation programs for people with orthopedic conditions, even beyond osteoarthritis. We may be able to target specific changes in the nervous system in order to improve outcomes and help people like Molly get back to their favorite activities.